In the previous video, we saw that declaring a global variable means giving a type to an identifier. And it does not, what it does is to tell the compiler that this variable with this type exists, but it does not necessarily reserve memory for the variable. And to define a global variable, we also reserve memory. And as we can see, or what we can see here in this slide, at least the first two also reserve memory. So if we initialize the variable, then the compiler will reserve memory for it. So this is fine. This is not portable, so don't use it. Some compilers really dislike seeing extern and initializers. This should not be used either. And the reason is that both the GCC and clang changed what is implementation defined behavior in year 2020. And it changed from what was common practice in Unix since the early 1970s. I will soon explain what happened. So, if we want to tell the compiler that there exists a variable, global variable with a certain name and type, then we should use extern int. And before this change to GCC and clang, we could skip the extern. And GCC changed this in May and clang in October. And I will now show what happened. So if we use the previous version of GCC and compile, I will soon show what program it is. Well, actually I can do like this. Okay, so it's this variable that is interesting, and let's see the symbol table of the file, and then there is a C for this variable. But with the current GCC, it will instead be a B. Okay, what does that mean? The C means these characters say in which part of memory the variable is located. And D is for data, and B is for something called BSS that I will soon come to, but C is for common, and that is global variables that have not yet been initialized. And if no C file, when the linker collects all the object files, had defined the variable, then the linker will reserve memory for it. So this is called common. And when I showed the video about object dump, I said I would use this -t to show the, well, I didn't say why, but it was to show the symbol table, and we can do that as follows. I forgot to use this example. So let's see. Oops. Object dump it should be. So now this is with version 10, and we can see variable B is put in this BSS. But if we use the first and then this, it will be in this section. Okay, and what are these sections? Well, we can use object dump again and see the name of the different sections. Okay, and these sections are reserved for, these sections are used for data that is in the object file. But this common, it's not stored in the file, so it's not listed here. It's just a special section number. So this index say, I mean, in the symbol table there is for each symbol there is a number here, not the text, and this number refers to this index here. So there is an index of that describes the different sections. I mean, there is an array of section headers that are and you use an index to find which one. But there is no section for the common. This is a special index number that all compilers on Unix systems with this ELF format, this format, use, and that is Linux systems and some other systems as well, but not the Mac OS. It uses a different file format called Mac-O, like that. Okay, so let's see one more thing about the this 8.0 file. If we do as follows: octal dump -c and 8.0, and just look at the first line, then we can see it starts with this is in octal, so it is 7F in hex, and 4 characters saying which kind of file format this object file is. Okay, and the first bytes in an object file, that's called a magic number. If we do as follows: read elf, and then we can see it says the start of this file has a header, and that's called, the very first part of it is called a magic number. So that's can be fun to know, perhaps. Okay. Okay, so that is what actually happens in the object file with the different versions of GCC and clang. Okay, so what should you know about this? To avoid problems as a C programmer, you should use extern int and not only without the extern. Since different compilers are used, and some use this new implementation defined behavior and others use the previous. That was since the early 70s. Okay, so let's look at different ways to make mistakes. If we use only extern, then the file will not, the variable will not be defined, so the compiler will complain. If we initialize it, even though we initialize it with the same value, this is false. This is wrong, I should say. So the compiler will complain when it merges these files. Okay, and this is also wrong, but it worked for a long time. So what we saw was that with the GCC 9, it put X in this common block, or common, well, it's called a common block, but the name of this area is called the section common. Okay. The name common block comes from how Fortran compilers were implemented. Okay, or are implemented. Okay, so with the recent version of the GCC and clang, X is instead put in the section called BSS, and BSS means block started by symbol, and this name is really complete nonsense and a historical rest. But as you saw before, both there are commands with this is used for in output from various tools on Unix systems, and it means global variables that are not initialized to any particular value. That means they should be zeros, and it's pointless to store all these zeros in the object file, so they are just created when the program starts. Okay, so this is a correct declaration. And this is another one. This was correct also previous years, since that one would become put in the common section, and the compiler will fix it in the end. If we want to use a global variable in different C files, then it's a very good idea to put it in a header file. So a header file should contain declarations with extern, and then the different C files can include this. It's very good to also include it in the file which defines it, since then there can be detected a type error if there is one.